So in this video, we're going to recap some of the, assumed knowledge of right-angled trigonometry in preparation for the non-right-angled trigonometry course from the Year 12 Standard 2 syllabus. Now, we're going to be talking about two particular things here. One of them I have at the top. So we've talked at length about Pythagoras' theorem on this channel, but this is assumed knowledge. So it's not covered in the Year 11 or 12 course, but just to quickly recap it, it's a formula that says that the square of one side, one smaller side, we'll call it A, added to the square of another smaller side, B, equals to the hypotenuse, the longest side, the side opposite the right angle triangle, C, all squared. So this guy here, C, is the hypotenuse. This just means the longest side on a right angle triangle. Now, we've talked about this before. Please look at any other videos if you want to practice substituting into the formula or rearranging the formula, finding the length of a shorter side, A or B. But this goes as assumed knowledge. I want to spend some more time on the trigonometric ratios in this video. So we have trig ratios, which we've talked about in the Year 9 and Year 10 course content, but we look at our right angle triangles and we give them three side names. Now, we are always thinking from the perspective of one particular angle. We have this angle theta down the bottom here. So our sides and how we name them depend on their position relative to this angle. Now, the hypotenuse stays the same. That's always the side opposite our right angle. Now, when we have this angle theta here, the side next to it, that's not the hypotenuse, obviously, is what we call the adjacent. So to be adjacent to something means to be next to something. So the angle that is next to our angle theta is the adjacent. The angle that's opposite, or the side, sorry, that's opposite to our angle is called the opposite. Now, something important that we'll talk about really quickly is that these sides, other than the hypotenuse, change depending on which angle we've been given. So if I was looking at this angle instead, if I was thinking in terms of this angle theta, my opposite and adjacent change. My adjacent, the side next to my angle, is here now. And the side that's opposite to my angle is this one down the bottom. So it's all relative to the angle that I've been given. Now, there are a few trig ratios that are basically equations that we end up manipulating when we deal with right angle triangles. Now, these three that we have to remember is that the sine from the perspective of the angle theta equals to the ratio of the opposite over the hypotenuse. The cosine of that angle in particular is equal to the ratio of the adjacent to the hypotenuse, and then tan here is the opposite over the adjacent. And there was a way we could remember this, which I've written down here, our SOHCAHTOA, which we've talked about at length on this channel. So now that we have the brief recap, we're going to get into some questions just practicing applying this to find the sides in unknown sides in triangles and unknown angles. And we're going to look at some harder questions right at the very end. Now it's saying find the length of the unknown side x in the triangle shown. Answer correct to 3 decimal places. So we've been given this angle. This is our angle theta. So we want to label these sides from the perspective of this angle. Now x is the side opposite to this angle. And 20 is next to it, and it's not the hypotenuse, which is up here. So this guy, 20, is our adjacent. So we go back to our SOHCAHTOA. We've been given the adjacent and we want to find the opposite. So anytime we have opposite and adjacent, we are dealing with tan. So we're going to say, to show our working out, we can say the tan of 35 degrees equals to x over 20. Now, remember, the operation here is that x is dividing by 20. So to get x on its own, to solve the equation, we're going to multiply it both sides by 20. So x is going to equal to 20 multiplied by tan 35. So we can just write this as tan 35. or 20, 10, 35, and it's assumed that these two are multiplying. So when we put this in our calculator to 3 decimal places, we get 14.004. So we are substituting into one of our trig ratios, then rearranging the equation. Now, for example 2, we're doing the exact same steps. So we always do the first couple of steps. We always identify the sides, decide on a trig ratio, write out an equation. Then the next step depends on whether we're finding a side or an angle. In this question, we are trying to find the size of the angle theta here. But we're going to do it in the same way. So we're given our angle theta. We want to give these sides a name. Now this side 22 is opposite our right angle. So that's going to be our hypotenuse. Remember, hypotenuse always stays the same. And the side 13 is opposite my angle. So 13 is going to be my O. Now, looking back, when I have opposite and hypotenuse, I am dealing with sine over here. So I'm going to say the sine of my angle theta equals to opposite 13 over my hypotenuse 22. Now, in this question, we're looking for the angle. So we're trying to find this angle here, and we take what's called the inverse sine of both sides, because inverse operations just mean opposite operations. Here, the inverse of dividing by 20 was multiplying by 20. When we take the inverse of a trig ratio, that means that we get theta equals to the inverse sine. So there's a button on our calculator, I'll show you how to get to this one, of 13 over 22. Now, to get to this guy over here, making a little note for you, we do something on our calculator. We press, if you have a kind of scientific calculator, a Casio one, which is what I'm using, you can press shift and then your trig ratio. So here I'm pressing shift sine. And you'll get this sign with a -1 at the top. You can do the same for cos and tan. You just have to press shift first. So in order to find this, we just have to put this into our calculator. So we're going to press into our calculator, shift sign, and then we're going to write the trig ratio. So 13 over 22. And this is going to give you 36.2215 ... Now we're going to talk about how to get this to the nearest minute as well in a moment. But on your calculators, once you get this thing here, you can press a button which looks like this. It's got a circle, like a degree sign. It's got one of these apostrophes and then 2 more here. This is your button, to convert to minutes and seconds as well. So with this one, we are pressing this button, and we're going to talk about this a lot more, but we have covered it in previous videos. This gives me, because we're rounding, approximately 36 degrees, 13 minutes, and 17.57 seconds. Now, when we round to the nearest minute, we're trying to round to the nearest one over here. So anytime we round, we look at the next thing to the right of it. That's what we do with decimals, for example. But we're looking at the seconds here. Now, the middle of our seconds is going to be 30. That's the midpoint between 0 minutes and 1 minute. So if our number here is something less than 30, we're going to round down. If it's 30 or more, we're going to round up. Now, 17.57 is less than 30, so we are going to round down. So we get 36 degrees and 13 minutes. Okay, next example. We are dealing with a worded question. And now remember, this video is just recapping all of the things we've already done in right angle trigonometry and just making sure you've got your head around it before we go into some of the non-right angle trig here. Now it's saying a plane maintains a flight path of 19 degrees with the horizontal, so with basically a horizontal plane, like the runway, after it takes off. It travels for 4 kilometers along the flight path, and it's saying to find correct to one decimal place each of these things. Now, the quality with which you are able to answer a word question depends on how good your diagram is. So our first step with any of these is to draw a diagram. I've written this in capital letters, and I'm going to even add an exclamation mark to really drive the point home. We need to draw a picture. That's how we're going to be able to effectively answer these questions, because they're easy when we have it in front of us. It's hard making sense of the words and drawing a picture, right? So we have our horizontal here. This is our horizontal. And the flight path is making 19 degrees with the horizontal. So here, I've got the flight path of the plane. Now, the angle it makes is 19 degrees. So I'm going to label that in here. And it tells us that it travels for 4 kilometers along this path, right? So I can label that as 4 kilometers. Now, what we notice is that wherever the plane is, if we draw a line directly down vertically, the vertical is always going to be perpendicular to the horizontal. So we can effectively make an imaginary right angle triangle with the horizontal and the flight path. Now, it's saying in part A to find the horizontal distance of the plane from its takeoff point. So the takeoff point is here. And we're trying to find the horizontal distance. That let's call X over here. So we're trying to find the horizontal distance from its takeoff point. So where it ends up, how far horizontally is it away from the takeoff point? So we're going to do the same thing as we've done in other questions. So we want to label the sides on our right angle triangle. Now, 4 kilometers is opposite to the right angle. So this is always going to be our hypotenuse. And this X is adjacent to, it's next to my angle 19. So that's going to be my A here. And I'm going to say, when I have adjacent and hypotenuse, so katoa, AH belongs to cos. So I'm going to say cos of 19 degrees equals to the adjacent X over the hypotenuse 4. And I want to rearrange the equation. We're dividing by 4, we're dividing X by 4. So we're going to multiply by 4 to get it to the other side. And we're going to do that to both sides. So X here equals to 4 cos 19. Once you have that, we just put it in our calculator. 4 cos 19 gives us, it's asking us to correct to one decimal place. This gives you 3.782 ... which is 3.8 kilometers to 1 dp. Cool. Okay, so we're breaking down the question and we are trying to find the unknown length. Now let's do part A down here and let's do part B over here. Now, looking at part B, it's saying find the height of the plane above ground level. So we're trying to find how high, this is where the plane is, how high it is from the ground level. So let's call that side Y. Now, this one is opposite to my angle. So this I can label O. Now, once again, we're considering the sides we're given. We have our Y side, which is the opposite, and we can use the hypotenuse because it's already a nice kind of number. That's what we're given in the question. You can use this number, but it becomes problematic because we've rounded, it affects the accuracy. So it's better just to use the value they've given you in the question. Now for this one, we know that opposite and hypotenuse is going to be sine. So sine of 19 equals to y over 4. And I'm going to multiply 4 to both sides. So I'm going to say y equals to 4 sine 19. I'm going to do 4 sine 19 in my calculator. I get 1.3022 ... which gives me 1.3 kilometers to 1 dp. Okay, last question before we wrap up. Now, this is taken from a past HSC question. So this is like one of the trickier questions you may get when you encounter right angle trigonometry in the HSC. So with this, we've been given two right angle triangles, triangle ABC. So this guy here. We've been given a smaller one, and we've been given ABD. So this one here as well. Now, we want to find, the thing we're trying to build up to is finding the angle theta down here. But we encounter a problem, okay? Because we see that this side, 35, belongs to this triangle. We have an angle of 41, but we can't really do anything at this stage with this one because we don't have enough information. We don't know what AD is or what AB is. We'll need one of these entire sides so we can use that with 93 to find our angle theta. But we can see that the side AB belongs to both right angle triangles. Now, if we can just find this and we have enough information to find this, we can use that value to find theta. So we're just going to consider triangle ABC. Now, we don't know what AB is, but from the perspective of the angle we're given, let's actually just label this side AB. From the perspective of the angle, 41 degrees, AB is the opposite. And 35 centimeters is the adjacent side. Now, when we have opposite and adjacent, so katoa, so tan is opposite and adjacent. So we're going to say that the tan from the perspective of the angle 41 degrees equals to the opposite, AB, over the adjacent, 35. So rearranging the equation, I get that AB is equal to 35 tan 41 degrees. Okay, so we're going to put this in our calculator, but we're going to be careful not to round too early, okay? So if I put this in my calculator, I am going to get 30.425 ... Now we're going to use the answer function in our calculator to find the angle, but this is just the answer we get. This is the length of AB. Now, if we look at this big triangle here, from the perspective of this angle theta, AB is still the opposite. See, it's opposite to that angle, and 93 is the hypotenuse. So I'm going to label this H. When we have the opposite and the hypotenuse, we are using sine. So we can say that sine from the perspective of the angle theta equals to AB, which is 30.425 ... over 93. So we're looking for an angle this time, so we're going to use our inverse sine. So our theta is going to be the inverse sine of 30.425 over 93. Now, this is what you're going to put in your calculator. Sorry, I've got the ... there as well. But this number here, because you've gotten it in your first part, you can just use the answer button on your calculator. And this way, it retains the unrounded answer, so it won't affect the accuracy of your calculation. So our theta, once we input this into our calculator, we get the inverse sine of our answer from the previous part over 93. And that gives you, we're asking for the nearest minute. Remember, read the question. Everything is there that you need. This gives us 19.095 ... degrees. And remember, we press that button to convert from degrees to minutes. That gives you, to convert from decimals to degrees and minutes. So we have 19 degrees, 5 minutes, and 45.38 seconds. Now this number here, the seconds, because we're rounding to the nearest minute, this number is a number that's 30 or more. So that means we're rounding up. So that means we have 19 degrees and 6 minutes. This is to the nearest minute. So So just a bit of a harder question to end on. This was a 4 marker in the HSC. So a lot of marks because we need a lot of working out to get to our answer. That brings us to the end of the video. Thank you so much for watching, and I'll see you next time.